Hello friends, welcome to my channel. Today I am going to tell you about some important numbers from fluid mechanics and heat transfer. First number is Reynolds number. Or RE. It is denoted by RE. RE is inertia force by viscous force. Viscous force. It is rho v L C by mu. Rho is density, v is velocity, L C is characteristic length or characteristic dimension, mu is our coefficient of viscosity or dynamic viscosity. We can write this one. We know kinematic viscosity is mu by rho. So rho vd by mu, we can write v into Lc by mu by rho. We can write kinematic viscosity VLC by mu. To distinguish between whether the flow is laminar or turbulent, the Reynolds number is very important. Next number is our Froude number. It is denoted by Fr. Froude number is root over of inertia force by gravity force. So you can write it as next number is our Euler's number. Euler's number is root over of inertia force by pressure force. We can write it as V by P by rho whole root over. Next is Mach number. M is inertia force by elastic force. Whole root over. It's V by C. Next number is our Weber number, surface tension. It is inertia force divided by surface tension force whole root over. sigma by rho L. It's Weber number. Then from our heat transfer, Reynolds number is important for both heat transfer and your fluid mechanics. In heat transfer, first is Biot number. This is for solids, heat transfer in solids. Biot number is very important. In all examination it's asking. Biot number is its conduction at surface of body divided by conduction within the body. Or it is internal thermal resistance by external thermal resistance. By external thermal resistance. RTH in conduction divided by RTH in convection. Biot number is HLC by K. H is convective heat transfer coefficient, L is characteristic length or dimension, K is coefficient of thermal conductivity. This is important for solids. Next number is our Fourier number. It is heat conducted by ratio of heat conducted by heat stored. It is also important for solids. Alpha T by LC square. Alpha is thermal diffusivity, T is time, LC is characteristic length or dimension. This is important for solid. Both Biot number and Fourier number is important for our lumped heat analysis. This one also asked so many times in IS examination. Out of the 4 options, which number is important for lumped heat analysis? They will give, and out of 4 options, one number will be Fourier number or Biot number. You have to choose that one for solids. Next number is Prandtl number. This is also very important. Or PR. It is the ratio of momentum diffusivity divided by thermal diffusivity. Divided by thermal diffusivity. Prandtl number. Kinematic viscosity by thermal diffusion. Or you can write mu Cp by K. Thermal diffusivity K by rho Cp. And our kinematic viscosity is dynamic viscosity by density rho. Here two important things are important. Prandtl number of air and Prandtl number of water. In all examinations they are asking. It's 0.7 for air and for water it's 3 to 10. At different temperature its value is different. Air and water. Air I think 3-4 times asked in IES. And ISRO also asked. For GATE also, for 1 mark question, this is important. Next is our Schmidt number. It is kinematic viscosity by mass diffusivity or momentum diffusivity by mass diffusivity. By ratio of momentum diffusivity by mass diffusivity. This is important for ISRO and IES. In GATE they won't ask, and other PSU examination also they won't ask. By diffusion coefficient. SC is thermal diffusivity by D. D is our diffusion coefficient. Schmidt number is important whenever there is simultaneous convection of mass diffusion and momentum. Next is our Lewis number. It is the ratio of thermal diffusivity by mass diffusivity. Ratio between thermal diffusivity and mass diffusivity. Thermal diffusivity by Schmidt number. It's kinematic viscosity. No? Kinematic viscosity denoted by this. And thermal diffusivity, it's alpha, and mass diffusivity D. D is the diffusion coefficient. Kinematic viscosity by diffusion coefficient. Lewis number. Thermal diffusivity by diffusion coefficient. Both are important for mass diffusion. Here in Lewis number, it is important for simultaneous heat and mass transfer. Sometimes they are asking in IES Schmidt number and Lewis number, they will ask. Next is our Nusselt number. This is very, very important. For GATE examination is also this is important. denoted by NU. For GATE also, for problem 2 mark question, they will ask to find out that value, or other things they will ask, which is related with Nusselt number. This is important for fluid. It is the ratio of heat convection when fluid in motion and heat conduction when fluid is stationary. This is very, very important for all exams. Fluid in motion and heat conduction. Sorry, it's convection. Heat convection when fluid in motion. And heat conduction when fluid is stationary. Nusselt number is HLC by K. Here one more thing is important. This was already asked in ISRO examination. Nusselt number is function of Reynolds number and Prandtl number. And one more thing, when Nusselt number is function of Grashof number and Prandtl number. This is for free convection and this is for forced convection. This is important for fluid heat transfer. Ratio of heat convection when fluid in motion and heat conduction when fluid is stationary. Convection by conduction. Next number is Grashof number. This is also important. Grashof number or GR. GR is buoyancy force by viscous force. Viscous force. Its value is, this one already asked in ISRO examination. And Grashof number is very, very important for free convection. Next is our Pacelet number or PE. It is Reynolds number into Prandtl number. It is important when this one also asked in IAS exams. Flow of liquid metal over surface. Next number is our Rayleigh number. In GATE they won't ask, but for IAS ISRO it is important. Rayleigh number is Grashof number into Prandtl number. It is important for already Grashof number is available. It means it is important for natural convection. Then next is Stanton number. It is important for forced convection. This is for free convection or natural convection Rayleigh number, and Stanton number is for forced convection. Stanton number is ratio of wall heat transfer rate to heat transfer by convection. This is very important. Nusselt number divided by Reynolds number into Prandtl number. ST is Nu by Re into PR. This is very important. Rho B Cp. It is important for forced convection. Next two numbers are there. They are for boiling and convection. They may ask in IAS or ISRO. For boiling and convection, 4 options they will give, out of which you have to choose one option. In one option you will find either Jacob number or Bond number. Both are important for boiling and convection. Thank you friends for watching my video.